is the second half of lesson 7.5. In this lesson, we will learn how to solve logarithmic equations. As you can see at the top here, we're going to solve them algebraically, graphically, and with a table. In this video lesson, I'm only going to show you algebraically. I'll show you the graphically and with a table in class. So, to solve this equation, we have to do the opposite of a log. So, since this is log base 10, if I put a base 10 in here, I can cancel the log. So if I put a base on the left, I have to put a base on the right. So this gives me 4x minus 3 equals 10 squared, and 10 squared is 100. From here, it's a linear equation. Add 3 to both sides and divide by 4. And that's it. But you do have to check your answer. So we would put the 103 in for x. If you put a 103/4 in for x, the 4's will cancel and you get 103. 103 minus 3 is 100, and log base 10 of 100 is 2. So yes, it works. That is the correct answer. Okay, in our second example, this is again log base 10 because there's an unwritten base here, so we know that it's base 10. If we put in a base 10 on each side, that will cancel the log, so we get 3 minus 2x equals 10 to the negative first. 10 to the negative first is 1/10, or 0.1, and then we will subtract 3 on each side, and we get negative 2.9, and then we divide that by negative 2, and we get x equals 1.45. Again, we have to check this to make sure it works, because sometimes you'll get extraneous solutions. So we'll put in a 1.45 for 2. So we have 2 times 1.45 is 2.9. 3 minus 2.9 is 0.1. And log of 0.1 is negative 1. So it works. We have another good answer here. These problems are more difficult because you have a log in here twice, and you can't put in a base 2 times on one side of the equation. So what we have to do is condense the log into one single log, and then we can put in a base. So using our rules for exponents, or properties of exponents, this addition tells us that we can condense this to a single log by multiplying. So that means we have x minus 3 times x equals 1. So if we distribute the x, we get x squared minus 3x equals 1. And now to eliminate the log, we're going to put in a base 10 because this is an unwritten base, which means it's automatically 10. So putting in a base 10 cancels the log. We have x squared minus 3x equals 10 to the first power. 10 to the first power is 10. Subtracting the x over to the left side, we get x squared minus 3x minus 10 equals 0. And then we can factor to solve. So when we factor this, it factors as x minus 5, x plus 2. And our solutions then are 5 and negative 2. And now, especially since we have two solutions, we need to check them because it's likely that one of them will not work. So if we put a 5 in here, we get 5 minus 3 is 2. So that gives us log of 2 plus log of 5. Condensing the log, that would give us log of 2 times 5 is 10, and we know the log of 10 is 1. So this first solution is good. If we put a negative 2 in here, we get log of negative 5 and log of negative 2. If you check with your calculator, you will find out that you can't take the log of a negative number. Log of negative 5 is an error. So the negative 2 here is an extraneous solution. In example B, we're going to again condense the log. So this one is subtraction. Subtraction, we know, turns into a division, so we have 6 divided by 3x. The 6 and the 3x will reduce, so we have log of 2 over x. Since this is again an unwritten base, it is a base 10, so we put in a base 10 to cancel the log. And we have 2 over x equals 10 to the negative 2. Negative exponent means make a reciprocal, so that's 1 over 10 squared. 10 squared is 100, so we have 2 over x equals 1 over 100. To solve this, we're going to want to get x out of the denominator, so if we multiply both sides by x, that brings x up to the top. Multiply both sides by 100. That gets 100 out of the denominator, and we end up with 100 times 2 is 200, and 1 times x is x. So if we check this solution and see if it works, we're going to have log of 6 minus log of 3 times 200 is 600. If we condense that log, that'll be log of 6 divided by 600, which equals log of 1 over 100. And we know from properties of logs that log of 1 over 100 is negative 2. So this does work, and this is a good solution. And that's it for this second lesson in 7-5.